it's done here, and this is part 5 of the FHANv version 3 design series. Now, in the previous 4 parts, we have already covered the creation of the layout using Keyboard Layout Editor. We've gone through in KiCad the development of the electrical schematics. We've gone through the placement and orientation of footprints and diodes, and then in the last part where I wrapped up, I started off by showing how to do basic routing of the electrical traces between your components. Now, I stopped that video rather than doing all of it, but I showed doing the first row and some of that row 0 and some of row 1, as well as how to connect up column 0. And I stopped it because it was going to be a time-consuming process. There's a lot of sort of messing around trying to find the best way to route your traces, as well as using vias, punching in and out of the front and back layers to be able to get where you need to go. I've completed all of that, I believe, and so let us check out what it finally looks like. There's the main PCB, and we'll see that there's a lot of green lines running vertically, which are our columns, and we have a lot of red lines that are running from left to right horizontally, which are our rows. So the bottom of the diodes are actually all connected up to a certain point, and then the top of the diodes are connected to the actual key switch, as it should, according to our electrical schematic. And similarly, the columns are running vertically down from each of these column connections. Now, when we get to around some of our areas of interest, such as the compatibility section, you can see there's some crossing over and routing, because this particular, now if I select the routing, the trace tool, it highlights, and you can see that we're connected to 2 switches on that diode, but the actual pathway for the diode to complete is only connected to 1, because it's just using that same one diode. And similarly, so our column is actually just running straight through all of those components. So it doesn't really matter, regardless of what's being in there or not. In theory, it should just connect all the way through. Now, when we go up towards the Pro Micro, it starts to get a bit messy, because there's a lot of creativity involved in hopping over and under traces and around. Some are going around the top, some are going through the middle, others are going around the bottom and out the sides. And this is why I didn't want to do it on the actual video, because it is quite a time and patience testing exercise if you're not experienced like myself, because you've really got to move around quite a bit to try and find, okay, where can I go? How do I hop around this? For example, this line here, I was hoping to get a bit closer, but I've actually had to go up and over, under again, up and over, and then under again, and then back all the way around internally to get to where I wanted to go, which was the last row, row 6. Now, of course, if you have a lot more foresight and planning, you can probably do this a lot easier, because you would position your rows and your switches and the Pro Micro and its orientation to be hopefully as clean as possible. You can see the columns that I've done here, column 0, 1, and 2, 3 are all relatively clean, except for one crossover here, 4, and then 5 comes along the inside, which is lucky, and then 6 on the outside. But it's the rows that really get messy rather than the columns. So that's the completion of the actual trace component. And one of the things that was, I suppose, a bit more experience over time is just knowing that you can go and do something crazy like hop around the outside and go all the way around the outside. I mean, if I really wanted to, I could have taken it down the bottom and all the way around, and it still technically would have worked. Of course, if you do run it on the outside, then you run a technical risk that if the outside edge of the PCB gets damaged, then of course your trace is going to get damaged as well. But we do have a good amount of margin there. As you can see, we've got a bit of margin there, so in theory, as long as you're not bashing the PCB around, it should be okay. Now, moving on to the next part of the guide and completing this PCB, of course, is we need to fill in some planes and to update our zones. So we don't have any missing ground planes. but let us fill in some zones, and there we go. We now I just pressed B as per the instructions, which is to update the zones, and we have a lovely looking PCB. And you can see all of these bits and pieces, and then of course if I turn our drawing layers back on that I had taken off, you can see the footprints and so on and so forth. This is when we start using the design rule check tool within KiCad, which is this little ladybug up here, just to make sure that there's no errors. And I have not run this, so if we do get any errors, you're going to see it first and foremost. In a way, I kind of want to see some errors just so that I can run through them on the video, but if there's no errors, then that's fantastic. So here we go. We're going to check. We're going to leave our minimum clearances and start finished. Okay, so we have a pad near a pad. We have a lot of pads near pads. And what does that mean? So we're looking at that pad. Ah, okay. So these are related to our vias, which is fine. 2, 3, 4, 5. Okay, so let's just check them all out to see what the issues are. And it seems like they might all be related to the mounting holes that we used. So, yep, that's a mounting hole issue. That's a mounting hole issue. Mounting hole issue. So it reads like all of these. Oh, okay. So what's this one? This is an actual switch related one, is it? I'm going to turn that off again. So let's just see, because you can see all of these, the reference is all related to the mounting holes. And then there's 1, 2, 3 related to actual key switches. So this first one, pad near pad, pad hole on 44 2U1 and 44 U1, which is, aha, okay, so we've got some overlap hole here, and that's okay because that's just a cut hole. It's really more about, as long as we've got the main hole and we've got one of these side holes, it should be okay. And that's for PCB mounted switches. Of course, if you're using plate mounted switches, it doesn't matter. Then we go on to the next one, 45 and 44, which is this next hole here. Once again, there's an overlap there. Then we go to, we've got a hole and half a pad. Now, this is of course for the stabilizer, and the pin will go through here. I don't think it's too much of an issue. Had I had this sort of flipped around the other way, then the bigger hole would have been there, or the switch footprint would have been down here. But then you're going to get a little bit of a weird orientation for that switch position. I'm okay with that. Half a hole, that's not a big deal because there's still plenty of contact surface there for the pin to be soldered to. It's not a critical error. And then it looks like the rest is all sorted. So I'm relatively happy with that. If there was any issues that needed to be fixed, they would be in red, critical. And I've had that before on the V2, so I'm really happy with that. Turned out really well. The previous errors that I had were ones that I hadn't connected completely the traces. So I'd clicked here, clicked there, but I hadn't double clicked. And when I clicked there and then onto the next point, it was assuming that it was just a single trace all the way across and it wasn't a connected trace. And so I had to go back and double click on every single one of the joints, which I've done this time. Now, we can have a look at this in 3D. Now, you do need to have additional stuff installed with KiCad called Wings 3D, I believe, which is what generates these. So you can generate that, and then I'm going to drag this over because it opened on my other screen. And here we go. That's the completed PCB. So this is what the PCB looks like from the backside, and you can see all these holes where the vias are going through. You can see all the trace connections. most of these are the columns, and then when I flip it around to the other side, you can see most of these are our rows, and of course the chaos that is over here near the Pro Micro. So it looks pretty good. We've got our corner holes, and we've got our middle support as well. Awesome. So from here we need to produce our Gerber files. Gerber files are the instructions that are used for the actual manufacture of the PCBs. Now, remembering of course that this is going to be the back, and I kind of want to put something also here in text, but I'll sort of get to that in a moment, so that when people build it, of course they build it with the correct orientation, and they know that the correct orientation of the Pro Micro is as well. So you need to produce a Gerber, but before you produce the Gerber you need to put down your text. You want to put down your silk screen and anything else like that. Otherwise, after you put on your Gerber, it's too late. It's too late to do that. So we need to insert some text. So here is a text tool. Add text on copper layer or a graphics text, and I want it to be on the back copper, because, well, actually I want it on the back silk screen, don't I? I want it on the back silk screen, and I'm going to add my text, and I want to say TX, chuck in a couple of spaces, and raw, because that's generally how the orientation of the PCB is going to be, and I'm just going to plonk it right there. And so what that means is, on the back of that PCB, you know that your TX corner is going to be on this, and the raw corner is going to be on that. And this is completed by the fact that if we go back to our viewer, you'll now see that TX is appearing here and raw. So when someone comes along to put on their Pro Micro, they know that the correct orientation of the Pro Micro is going to be with the TX in that corner and raw on that corner. Now, I do not have this designed or built with obviously a switch for reset purposes. You'll just have to short the pins normally, only because there is a variety of different switches out there, and I didn't want to limit anybody to a particular style type design. It's very easy, of course, to get your own and solder it between the ground and reset pin, and just zap it yourself or touch it with a screwdriver or whatever it is that you desire. Now we want to add some more pretty things. We can, but we really don't want to add a silk screen on the back, because if we do, we're going to cover up our key assignments, our key map assignments of the K numbers and the D numbers, which is why we filled them in the first place if you had to do some diagnostics, or if you wanted to do some key mapping and that kind of thing. Of course, that leaves us with the front. So we go to our front silk screen layer, and then we can put down stuff. And just trying to remember, how did I add an image? There's a tool here for it, wasn't there? Cuckoo. Just trying to remember how I did it last time. You can tell I do this a lot, right? That's right. I think I had to add it as a footprint, didn't I? I had to add it as a footprint because what you do is you actually save it as a footprint. Now, of course, there is more extensive. See, there you go. We got some footprints. There's extensive kind of things that are out there to help you understand and create footprints, as well as images into footprints. And look at how tiny that is. So we're just going to delete that footprint because obviously it was too small. Search by browser, and we're going to go with the big one. Oh, okay, too big. Let's get rid of that. Let's have a look. Is it the 800? There we go. 800 DPI, and we can put it somewhere fancy. I don't know. I could put it in the middle, but then it's just going to be a bit weird because that screw hole is going to be there. So maybe we'll just center it like that. Bam. There's our front silkscreen. And then if we want to add text, which we will do down here, because there's a bit of open PCB space there, we can say fan version 3 by of course have to put my Reddit tag in there. Ooh, can't even spell my own name. So there you go. Now, of course, you can see where it's going to sort of sit and how it's going to sit there, but we can edit that tool. We can edit it because we want to justify it left justified, and then we can drop that onto the next line. There we go. And now we can move that around. Maybe. Let's see. How does that fit in? As long as it's not gonna. Well, I shouldn't have to worry about the purple stuff anyway, because the purple stuff's gonna be at the back. And then maybe on this side, let's put what I wrote last time. Function key. Well, what do I call it? F row. Unblock. Oops. Although technically it's a nav cluster, but people call it a nav cluster, and if you do that, then it'd just be like which isn't as nice. Arrow keys, and then numpad. All right. We're going to go left justified as well. Just like that. Okay, so F row keys, home block, arrow keys, numpad version 3 by me. And there you go, the board. So if we just save that, and then once again, we open up our 3D viewer and checking it out from the back, swivel it around, and bam, there you have it. FHANv3 by Donald Chu. F row keys, home block, arrow keys, and numpad. Our screw holes for the standoffs, all of that. And then on the back, we've got our diode placements, we've got our switch placements, we've got our TX and our raw. So that is pretty much ready to go for the purposes of making a Gerber file. Let's close the viewer. It's already saved. Now, to plot our Gerbers, we're going to use the Gerber plot button, which is up here. And there's a bunch of features that you want to make sure that you use, or the correct one. So we're going to use the proto file name. Yes, use the proto file name extension, 4.6 unit millimeters. Now we want front copper, front silk screen, back silk screen. We want our pastes, because that's going to be where those solder pads will live. We want our masks as well. We don't need the user drawings, I don't believe. And we definitely want to have edge cuts, because if we don't have edge cuts, we're not going to see what we are cutting out. So we don't need those plots references. We do want to exclude PCB from other layers. Default line width, yes. Everything else looks good. And let us plot. Okay, so it's created some plot files. Then we want to create some drill files. Generate drill files. Now we are going to have to do some output directorying. So that's into the FHANv3. I'm going to use an absolute, not a relative path, just because that's the way that I prefer things to be. Make sure it's postscript, make sure it's decimal, make sure it's inches, minimal header, absolute origins. Let's see, what else have we got down here? Okay. That looks to be good. So we're going to click on drill file, and it creates the DRL and the non-plated through-hole drill file as well. And now we need to pack all of these files into a zip file. So we can close the dialog, close the dialog. Now if I open a new window for the FHANpad, here it is. Let us have a look. View details, a little bit easier, and all the files that we want. What I'm going to do is new compressed zip file. I'm going to call that FHANv3 Gerbers. So I want all these Gerber files. I don't need the library. I need the cuts, copper, mask, paste, drill. I don't need the schematic, the pro, the net, all my backups. I do need the drill. So I'm going to copy all of those, going to enter the zip, and I'm going to paste them inside there. Rightio. So that is done. Now you can actually check out the Gerber. So there is fancy things like this, which is online Gerber viewers. And what you can do is you can choose to open up the Gerber. Hopefully it'll load correctly. Waiting for it. And now we can check out, that's the back copper plane. That's masking, the paste, front silk, well, back silk screen, sorry. There's the edge cut. There is our ground copper, the other mask. I don't think there's anything in the paste. There's the front silk screen. There's the drill holes, and there's our non-plated drill holes. So that should be it. Then it's pretty much ready to go. So if I hop back to the guide, the magic guide, there we have it. So we do have in our zip file there, just to sort of follow through, we have the drill file, we've got back copper, mask, GBS, GBP, GBO, edge cuts, front copper, GTL, GTS, GTP, GTO, and drill file. And as you saw, it loaded into the Gerber viewer and it worked, and there you go. Nice, packaged, ready to upload. Now, previously I had used all PCB as my prototype manufacturer, and I'm probably going to go with them again. I'll obviously have to get a quote and see how much it costs and whatnot, but that's the process from start to finish to create the PCB. Hopefully you found the video helpful to understand the process involved. It's actually not that hard. The hardest part really is for me to do the tracing. The other parts, it's just a bit of practice and knowing how to do what you need to do. And to make life easier, if you have your matrix all mapped out, just like I did at the start, then it's a lot faster for both the electrical schematic as well as laying out your components, the physical layout on the PCB, as well as when it comes to doing your traces, because the rat nest really helps you understand, because it highlights where connections have to go. So at this point in time, it's just a waiting game of having a bit of cash, putting this up to be manufactured, getting them, building a prototype test unit, and then if it works and it's all hunky-dory, then going back to the community to see if people want to get one or not with this new revised layout. So thank you very much, of course, for watching through this entire series. If you've been here from start to finish, in all the various parts that were involved in it, and I hope it made sense. I hope it's useful, and it will encourage you to go out and develop and create, play around, and design your own PCB. Massive thank you and shout outs, props to Ruiki Mao for that really fantastic guide. It's just that a matter of not using, say, a crystal or a microcontroller and using the Pro Micro or a Teensy, because you can get footprints for Teensies, which makes life a lot easier if you are not trying to design an SMD component board. Am I likely to go down that path in the future? I don't know, yet to see, but at this point in time, probably not. Rightio. Thank you again. If you have come across this channel and you don't know what the Board Podcast is, please check it out at www.theboardpodcast.com, a podcast series all about mechanical keyboards. If you haven't subscribed to our YouTube channel and you've somehow come across this video series, then we would really love and appreciate it if you would go over and hit subscribe. It helps us heaps in terms of getting more visibility and more people being able to see and finding our content, just even randomly with how YouTube suggests content for viewers. So yeah, and of course, as I like to finish off every time, until next time, happy clacking.